bigger. Right? So if we look the behavior, how it behave according to the forces. Okay, if the forces like this and the material touch the floor very rigid, cannot move. So what can move is the upper one. So if the P is very bigger, right, you make the angle bigger. If the P is small, you make the angle small. Same like this. Okay, the deformation for shearing stress is sudut gamma. Okay, alpha, beta, gamma. Okay, so alright, the deformation here is delta because you try to pull it like P. The deformation for this kind of forces, horizontal, is T gamma. The bigger your force, bigger your gamma. Bigger is your P, bigger is your delta. Alright? So if this one strain, if this one is stress, P, okay, divide by A, alright, and strain is delta divided by L, and you plot the graph, and you have the E here, E, alright, E is stress divided by strain, right? But here, okay, stress is called shear stress. Deformation is angle, right? Like, okay, and then how to measure the angle is delta, how much he moved delta, divide by L. So tangent equal to horizontal movement divided by L. Okay, so if you plot sigma and strain, and if we plot shear with gamma, so we come up with the G. G is shear elastic modulus, modulus of rigidity. Today you learn another words, another terms, modulus of rigidity, related to these properties, these materials, like this bridge. Okay, so the shear stress is P divided by A. The strain here is delta, okay, but the strain here is gamma. So gamma, if you use tangent, tangent equal to delta divided by L. Okay, so if you plot what is the relationship between stress and strain for this material is G, as we have E equal to sigma divided by E, sigma divided by strain. So sigma equal to E strain. But here, all equal to G gamma. Okay, so this material have another properties called modulus of rigidity, and this popular called modulus Young, modulus of elasticity. So this one have G. Any questions? Faham? Tolong jawab seorang. Tolong jawab, buka suara.
Doktor.
Ya, faham? Faham?
Faham, Doktor?
Okay, please answer. Okay, so saya bolehlah terus kalau ni. Okay, so ini bentuk stress and shear strain bagi this kind of material, which is the force is parallel to the surface. Yang ini kita dah belajar stress and strain tension members. Okay, so this one keluar E, modulus of Young. Di sini keluar modulus of rigidity. Okay. Okay, gabungan antara G, every material ada E, semua saya dah cakap. Starting from that lectures, okay, all materials must have E. And starting from today morning, all material also have G. Okay, ada G. Okay, and material also behave modulus, Poisson ratio. So if you have the books, you can refer how they derive. If not, this is the combination of G equal to E divided by 2, 1 plus Poisson ratio. Okay, so you can play around another formula here. Okay, look the form example. A rubber type of material with 10 millimeter thickness has a G value of 0.75 kilonewton millimeter squared. Placed between two plates to absorb a shear force P 150 kilonewton as shown in the figure. Determine the shear stress. So shear stress is a force parallel to the area. So the student should know which area. Okay, so this is the area. The green area, the green. Okay. So this is the initial stage when P equal to 0. Okay. When P equal to 0. So when P equal to 150, this one cannot be moved. Okay, because it's a rigid. Okay, dah padat, dah glue dekat sini. Welding. Cannot move. So he only can move left and right. So the bigger the load of P, the bigger your angle. Okay. If P equal to 0, angle is equal to theta, equal to 0. Okay, same like this one. Okay, when P equal to 0, there's no forces. There no forces, no deformation. But when P equal to value, okay, this is your deformation. So, all right, same goes to here. But because it is rubber, all right, so the deformation is movement to the left, okay, and he tried to create the gamma here. So determine the stress P divided by A. So A is 50 multiplied then 25. Determine the shear strain. Okay, you can use formula shear equal to rigidity multiplied by angle. So you can calculate in terms of radian. Okay, must have the same unit, upper one and lower one. Okay, so this is your sudut gamma. Determine the elastic modulus E. You can use equation here. And determine the lateral movement. Okay, let's determine the lateral movement. So this is tangent. Equal to delta divided by 10. Okay, or sudut you ambil daripada sini pun boleh. Okay, so boleh dapat. Movement is 1.6. Okay.
Total.
Ah,
Is it the gamma must be in radian?
yeah, in radian.
Okay.
In radian, okay. Not in, you must change it to radian. If you want to multiply by a degree, you calculate. Okay. Can someone read this question? Question number 9. Boleh seorang baca? Okay, Huiyin. Huimin.
A plastic block which is strongly attached at the base and also strongly attached at the top with a plate is subjected to force P as shown in the figure Q9 if the value of G equal 400 N over Mn squared. Determine the horizontal deformation of the plate when P equal 45 Kn.
Okay, so they ask you to determine the value of, okay, this one. Okay, so what is the, can you take out your buku latihan? Okay, oh, okay, so determine the horizontal deformation. So this is the horizontal deformation. Okay, What is the answer? 0 point. What is the answer? Okay, correct. This answer by Farah Ilya Hanim. Aisyah 0.0083 ni apa?
Salah kira, Doktor.
Okay. Jawapan betul berapa? Okay. Okay. Ada soalan? Okay, sekarang kita lihat keadaan. Boleh saya sambung?
Boleh.
Boleh.
Okay. Sekarang kita lihat keadaan tidak ada beban. Okay, tidak ada beban yang dikenakan pada member. Okay. Sebab awak punya subjek sekarang mechanic of materials. Apa kemungkinan berlaku pada material? Okay. So sekarang, alright, kita ada matahari. Okay. Okay. Alright. So the materials, okay, sometimes the elongation is not due to the forces. Okay, sometimes, okay, the elongation happen to the members is not due to the forces. Not, okay. So, if you put your material under the sun, okay, and the temperature increase, okay, and the temperature increase, the member also can be elongate. Okay. So this called due to thermal suhu. Alright. So not every time the material will elongate due to forces or shortening due to compression force. The material can behave deformations, okay, elongate if you put your material under the sun or due to temperature. Okay, so okay, the initial length is L when P equal to 0. So when L equal to 0, when the initial length, okay, all right. So when at local temperature, at current temperature, okay, and this is the actual length at the current temperature. Pada suhu sekarang 23, 32 or 28, this is initial length. But what happen if you increase the temperature until 1000 in kapal terbang, or in process of cement? So you have to burn the arang batu. Okay, you have to burn the silo. Okay, the equipment. Okay, all right. So you increase the temperature to a certain degree. All right. Remember, in the process of cement, that material have to burn. Okay, so your material for that particular container you must calculate its due to thermal expansion, the to thermal stress, or sometime in the railway station, railway track, okay, due to in certain country, their temperature during the summer is very high and during the winter is very low, -20 sometimes in America, alright? Okay, so same goes to these materials. If you put the compression, alright, the material will shortening. If you etcher without any forces, this material will elongate. Okay, due to what is your temperature, increasing your temperature. And during the winter, today is 32 is the actual length, but during the winter, negative, all right, 20. So it was shortening. Okay, it was shortening, right? So L is actual length during the current temperature. During the summer or during the process of this factory, sometimes you increase the temperature. What happened to this equipment? Is it elongate? If you increase the temperature for your kilang, all right, what happened to this container? And same goes to during the winter, or you bring it to the Mount Kinabalu, or you bring it to cold wind during the winter. What happened to this Even though the deformation is small, 0.001 millimeter, still called, all right, deformation. Don't say that, all right, how much deform, okay? And you sometimes you can see by naked eyes, especially the good example is during your railway track, okay? Okay, when the weather is the hot weather, the rail track will be expand, and you must allow the deformation happen, then you must put a gap. Okay, during the at night, the temperature drop, it will bring back to the original position, or it will be shortening. All right, so this is a good example lah. If you stay beside the railway track, okay, you can see there's a gap. Right. Consider one rod AB with a uniform cross section that is placed on the smooth surface. If there is a changes in temperature, the rod will elongate with the amount of delta T. So here we call T temperature. Okay, now previously we have delta, okay, epsilon, gamma, now ada delta T. Okay, so T stand for temperature. Okay, so what is a delta T? Delta T is, so here is your temperature, current temperature. Alright. So increase to 70. Okay. So the delta T is 50. Oh, sorry, 40. Okay. So the delta T is 40. Alright. So this is the current temperature. If you go to negative 20, okay. So the delta T is 50. Okay. So kena tengok. Ini ialah 40. Ini adalah drop 50. Okay. So jangan confuse. Alright. So delta T is changes in temperature. So jangan 30 tolak 20 jadi 10. Salah So kena tahu dia ada kosong dekat sini. So dia drop sebanyak 50. Okay. Yang ini 30 naik 70. Dia naik 40. So delta T you must have that kind of ideas. Okay. So what is the relationship between delta T equal to alpha delta TL? Okay, alpha delta TL. So how much the material elongate or shortening is alpha delta TL. Alpha is thermal expansion coefficient. In 1 degree, what is the value of expansion? 30 km sejam, okay? Okay, so in 1 hour, you can drive 30 km. So this is your velocity. Okay, in 1 hour, you drive 30 kilometers. That's called 30 kilometer per hour. For one increment, okay, for one increment of temperature, it increase this expansion. So if your degree is very bigger, Okay, so you have very bigger. Okay. Okay. So 70. In one, okay, in 1 degree, alright, it increase banyak ni. So kalau 70 degree kali banyak tu. Right? So at least ada pemanjangan lah. Ada elongation. Daripada panjang asal, strain adalah elongation divided by actual length. So this is your equation. One steel bar with 300 millimeter length tied on one end and free on the other end exposed to the temperature 30 degree. If the temperature increased to 75 degree, calculate the total elongation delta T and the strain. The thermal expansion is 13.1 multiplied by 10 power of 6 per centimeter per degree. So you must change the unit according to the temperature. So kalau dia sini Fahrenheit, sini Fahrenheit, sini Celsius, you kena tukar. Okay. So there's no forces, but due to temperature, so it will elongate. Sikit pun kena kira ya. Okay. So berapakah dia telah elongate? Alpha delta TL. So alpha 13.1, delta T is 45, L is 300. So even this is small, still you must calculate it. Okay. Okay, we use this knowledge on the structures now, composite structures. Okay. Calculate the stress in segment AC and CB for the steel bar when temperature decrease from 25 degrees to negative 50. So the idea is, right, we release one support and allow two shortening because it's a 25, okay, kosong 50. So this is your delta T. Okay. All right. So this is decrease mean the material will shortening. Allow it to shortening by, alright, dalam suhu, dalam bab thermal, dia tidak mengira luas. Dia hanya mengira panjang. Besar mana pun sama. Okey, maksud saya, kalau ada satu yang kecil, satu yang besar, okey, dua-dua ada akan alpha delta TL. Okey, formula dia ialah alpha delta TL. Okey, dua-dua akan pergi panjang yang sama. Dia tidak mengira, okey, size. So kalau sini 300, sini 300, dia akan panjang sama. Sebab formula ialah alpha delta TL. Okey. Kemendekan atau pemanjangan bagi suhu bergantung pada saiz cross section. Tidak, dia bergantung kepada panjang. Knowledge tu sangat penting. Okey. Okey. Oleh sebab dia disejukkan dan cara dia ialah lepaskan support. Okay, so dia akan shortening. So this is your actual length tadi. Okay, so this is your actual length. So alpha delta TL is 0.54. Okay, this is very rigid. Actually, we not allow it to shortening. Rigid means it's perfectly held. Okay. So what happened? We must have one forces try to pull back. That forces will pull the element back. Okay. So P. So we use PL over LE. Okay. P will. Okay. P will effect by area. PL over AE ada area. Alright. So how much you must pull it back to the original position, delta L. So this is your, okay, R. So the force acting on these two segments is P1 and P2 and equal to R. Alright, PL over AE. So this is the amount that you need to pull it back to the original position. So delta T equal to delta R. So RB is 96 kilonewton. The question now is stress. Okay, the question now is stress. So stress is P divided by A. Okay, alright.